This is an introduction to hypothesis testing. So the first thing that we're going to talk about is kind of the basics of hypothesis testing. So first of all, you should know that hypothesis testing is done to make inferences about the population. What we have in hypothesis testing is an assumed set of information about what's going on. And then, in addition to the assumed of what's going on, we have a claim that is wanting to be made. So there's this assumed info about a population. And then there's this other thing called the claim. And what we do is we hold sample information up in order to test and see if what's being claimed is actually what's going on, or if we can't quite claim that and we just have to fall back onto the assumption. So sample info is used to test a claim. So the thing is, in hypothesis testing, there's lots and lots of information that comes in a hypothesis test question. And that information is going to tell us about what the assumptions are, what the claimed information is going to be, and about what the sample information is. And you have to have the claimed and assumed fallback in order to use a sample to test it, test the claim. Now the thing is that this assumed and the claimed, there is a link between these two. And these two, even though they're not the same thing, we're going to hold it up and we're going to say, okay, if it's not one and then it's the other, so that we have this complement idea between the two of them. So the way that I want to introduce hypothesis testing is by actually looking at an example. So here is our example that we're going to use, and I've used a medical example, which is a qualitative example, because I can put a little bit of emphasis on how important it could actually be in having our decision be the correct decision. Because a medical example, you can see that there can be a life or death situation involved in that, and that's not the case in most situations. So our example says a manufacturer of a new medication is testing it against an old medication that has a success rate of 60%. So that is the assumed information here. This is assumed that the success rate is 60%. And that is what we're going to be denying or making some information claim about in terms of a hypothesis that we'd like to make. The manufacturer will not accept a new medication unless its success rate is better than the old. So in other words, what we're saying is, okay, this is the old rate. We have to be better than that 60%. And if we're better than that 60%, then we're going to be saying that, okay, well, the new medicine is okay to use. So the manufacturers, if they're not very sure about this information, they'll lose money, and they possibly might even be investigated by the FDA. And you definitely, when you're a drug manufacturer, do not want the FDA getting on your case. It's really bad form. So this is an important thing to get right if you're this drug manufacturer testing this hypothesis. So the first thing that we want to do in hypothesis testing is we want to write the hypotheses. Now there are some things about the hypotheses that you need to understand. So the things that we need to understand are that we have a pair of hypotheses. We have the null hypothesis and the alternative or research hypothesis. The null hypothesis is labeled H sub 0. For null. And the alternative or the research hypothesis can either be labeled as H sub A or H sub 1. I'm partial to the H sub A notation. Now some of the things that we need to understand is that there is a parameter that we're wishing to test in the population, and it is that parameter that belongs in both of the hypotheses. So we're wishing to test the parameter of the population proportion. We're testing what we call the p's. So that p is going to go into both of these hypotheses. And then the other thing that you need to know is that the number that we're testing, the claim that we're testing, is also going to go into both of these. So we want, or we have in the original information, that the success rate was 60% under the old medication. So we have 60% here. This could be written as 0.6 or as 60%, whichever you want to write it as. I'm again a decimal person. And you see that that's in both of these hypotheses. Now the claim that we make is that they won't accept the new medication unless it's better than the old. So we want an inequality that goes in here that tells us better. So that's our research claim, right? That we want it better than 60%. Well, better means greater than. Now, the claims are the null and the alternative are complements of one another. So if this is greater than, then this one is less than or equal to. And some books will just say you just put equality in there. I am not of that mind because these two things are actually complements of one another. We have two distributions going on, the distribution under the null hypothesis and the distribution under the alternative hypothesis. And what we're looking to find is that this distribution is different enough from this one that it lands us in a tail under this distribution and shows us that we're actually dealing with a distribution that is quite different than that. So the last thing that we really need to understand is that the alternative, the research hypothesis, no matter what, never, ever, ever contains equality. We try to steer clients away from asking questions that contain equality because equality cannot go into the research hypothesis. But if it's not possible to steer someone away from asking a question where equality is contained within the alternative hypothesis, then what we must do is we must put that into the null hypothesis because equality just cannot be included within that alternative ever. There is no circumstance which mean that can make you put an equal sign in here. It is not allowed. So what we have going on is complements, equality always in the null hypothesis, alternative never containing equality, and hopefully, and sometimes this won't be able to happen because of that equality problem, hopefully the alternative is indeed what you want to prove, your research hypothesis. Now, based upon these hypotheses, what we need to decide is where is the critical region or the rejection region going to be? And that has to do with where the tail of the test is. So you remember back when we talked about probabilities, and we talked about a probability being if it was really small, then we were looking at something that was unusual. Well, hypothesis tests are based upon that idea that when a probability is really small, it's very unusual. And where do we get small probabilities? Well, we get small probabilities when they're in the tails, right? So this tail here is going to give us a very small probability, something that's less than 50% of a symmetric distribution here. And so this little teeny tiny probability is what's going to help us to reject a null hypothesis and accept an alternative hypothesis. In other words, to prove our claim. So what we look at is the tails, and those tails are determined by the inequality in the research hypothesis. So we're saying that if we get a value that's above a certain standardized score, it's going to show us that there's very little probability. Or if we get a value that's below a certain standardized score, there's a very little probability of that under the distribution in the null hypothesis. And therefore, it's going to support that our population is actually different than the considered population, the one under the null hypothesis. And sometimes we don't know which tail it would be in, right? Is it going to be small in the upper end or small in the lower end? And so then we would get the two tails. And again, the way that we tell that is, the way that we tell that is by looking at our research hypotheses inequality sign. So our inequality, if it's greater than, then we're doing what we call an upper tail test. And if this were a less than, then it would be a lower tail test. And if it's a not equal to, then it would be a two-tail test. So we have a greater than, and so we have a one tail, and it's what we call an upper tail test. And that's all explained here in the three sets of hypotheses. So we have a P, because that's our population parameter. You see these are set up in terms of mu's so that you can see the two different types of parameters that we deal with. And for right now, these are the only kinds of parameters that we will be dealing with. Later on, we'll test hypotheses about standard deviations as well, and those will give us another parameter yet that could belong in these hypotheses. So we have proportions in R's and a possibility of a mu and a possibility of a sigma. And you see when there's a greater than in this alternative, we have a one tail test. It's called a right tail test or an upper tail test, and that means that our region of rejection will be in the upper tail of the distribution. Now, the less than symbol would mean that we would have a lower tail test or a left tail test, and that would mean that our rejection region will be in the lower tail. So if we get values that are down in here, it shows us that we have something that's very unusual under the null hypothesis. And finally, if we have a not equal symbol, that's a two-tail test, because we're not really sure, is it going to be in the lower tail or is it going to be in the upper tail? So for our example here, we have our hypotheses, which I show you right down here, and this sets us up to be an upper tail test, so just like we've seen here. Now this rejection region, what the rejection region is this shaded in over here, and sometimes this area is called a rejection region and sometimes it's called a critical region. So let me redraw it over here. And the tail of the test helps us to determine where this region is. So this could be called the critical region, or sometimes also more often called the rejection region. So critical region or rejection region. And this is going to tell us if we get standardized values from our sample that are in here, then they're unusual in consideration to the original distribution, the assumed distribution, the null hypothesis. And then that tells us that we're going to reject. This, by the way, is not test statistic. Let's see if I can change this. This is actually a critical value. So this is what we call a critical value inside of here. And this critical value is based upon the sampling distribution. So this is based on a sampling distribution. And that is based upon the parameter that you are trying to estimate. So that's the thing that we need to discuss. Next is how do we determine what value this critical value will be and how will we get to that? So I'm going to hold off on that until we get to the next video because I'm just about out of time. So we're going to talk about sampling distributions for different population parameters estimates in the next video.